This is video number 1 of 4.7, Transformations of Polynomial Functions. And in this video, we are describing the transformation of f represented by g, and then graphing each function. So for our core concepts here that we want to talk about, we're just going to start with the translations. So we have a horizontal translation if we have a number grouped with x, so it's in parentheses with x, and it moves us left or right. Okay? So if it's a -5, it actually does the opposite thing. Instead of going left where x goes negative, we're going to go to the right. And that's all because it's x minus h. Okay? And h is really just the 5. So that's positive units, so it'll go right. And then if it's an x plus a number, you actually go left. Now, outside, when you have a number not in parentheses with x, you have a vertical translation. So that's going to shift you up or down. And it does what it says. So if it is +1, y is positive going up, so you're going up a unit. If it's a negative, you're going down. So if we try to do that with number 1 in the example, it wants us to describe each function, and then we're going to graph it. So let's first do our description here. Our parent function here was x of 3, so there was no translations. But now all of a sudden we have something grouped with x, and we have a number tacked on to the end. Okay, so if it's grouped with x, it's actually the opposite thing. So we actually are going to go negative, okay? But think of x, and that x-axis is right here, and it's going left and right. But instead of going to +5, we actually go -5. So this is going to go left 5. That's what that part tells us. And the +2 is going to move our function from 0, 0 up or down. Well, it's positive, and y goes positive going up. So this is going to make us go up 2. All right, so we can at least graph a starting point by going from 0, 0, left 5, up 2. So left 5, up 2. There's going to be a starting point. Okay, now this is a cubic equation, so I need some other points to plot. All right, if I plug, remember the parent function is y equals x cubed. Okay, so for here, whenever I'm thinking of y, I take x and I cube it. Okay, so if I'm kind of ignoring everything else, I'm just going to deal with this parent function here. So if I cube 1, if x is 1 and I cube it, I still get 1. But I can also say x is -1, and I cube it, and I actually get -1. If x is a -2, you get -8. And if x is a +2, you're going to get a +8, because 2 times 2 times 2 is 8. And since it's an odd power, the symbols stay. So if I just start with these points, okay, just based on the parent function, and I use this starting point, instead of the parent function being a 0, 0, it moved over here. So from this point, I'm going to go -1, -1, or 1, 1, okay? Because there is no a, so I don't need to multiply y values by anything. So from here, I'm going to go left 1, down 1. That was that point. From this start point, I'm going to go right 1, up 1. That was this point. From that start point, go -2, down 8. And go right 2, up 8, which is off your graph. So this parent function is going to look, this function, it's not a parent function, is going to look like that. Now, if this confuses you, I just find it easiest I can come up with these points without using a calculator or anything, using the parent function, and I just know from that starting point, I'm going to graph those points. If that confuses you, you can use your graphing calculator and come up with points. Okay, we know no matter what, we're going to have that point, which was negative 5, 2. And so if I go to my graphing calculator and I type in the equation that this gave me, and I go to the table, it gives me points. Now I'm going to move up so I can, and you can see where it goes off your graph. So negative 8, negative 25 is quite off the graph, negative 7, negative 6, negative 6, 1, negative 5, 2, negative 4, 3, negative 3, 10 is off the graph. Okay? And so if you look at what we plotted, obviously this one's off the graph, which was right. We're continuing down off the graph. That's negative, negative, okay? Negative to the left and down and off the graph. So we did that. Then negative 7, negative 6, we got that when we went negative 2, negative 8 from our starting point. Okay, so negative 6, 1, negative 5, 2, negative 4, 3, and negative 3, 10. Okay, so you can choose either of these methods to get your points to plot your graph. And now that I have this entered, I can also graph it and check that that is what it looks like. Okay, I obviously could have made my curve here a little flatter, but for the most part, that's the function. All right, so let's try this with number 2. All right, so number 2 is now not an x cubed function. This parent function is x to the 4th. Grouped with x, I have a minus 3, and remember, instead of going negative 3, it's going to do the opposite, and it's going to go right 3. And then the number tacked on the end is a minus 1, and that moves our y value, okay, that moves us up and down, and it goes to minus 1 going down. So I'm going to go down 1 based on this and this. Well, and with that sign, but we do the opposite thing. All right. So again, if I put my starting point, I go right 3, down 1, there's my starting point. Okay? So if I'm going to make a chart based on the parent function, okay, and remember it's y equals x to the 4th, I know I have, well, let's start with, I moved down here. So if I start with 1 and I take it to the 4th, I get 1. I don't put in 0 because 0, 0 is really this point right here, okay? And then if I plug in negative 1 and I take it to the 4th, I get 1. I should have left room for negative 2 up there, but I'll put it down here. Negative 2 to the 4th would be 16. And 2 to the 4th is 16. So, like I said, you could do it that way, or you can plug it in your calculator and make a table, or just plug numbers in and figure out what you get for y. And we can plot these points. So, from my start point, I can go left 1, up 1. And I can go right 1, up 1. Okay. If I go left 2, up 16 is way off my graph. So I know it's pretty steep. So I'm just not even going to go over that far. So it's going to look like that. You can always check it with your calculator and also get the other table from your calculator if you struggle with just using the parent function points. The y's of these didn't change because there was no a here that was greater or something other than 1. Okay, so now I want you to go to the practice and do problems 3 through 10.